So the final tool that we have to estimate the derivative of a function at a point is going to be to use a little bit of technological assistance, which in this case is going to mean our calculator. So let's consider the function f of x equal to x to the fourth plus 3x cubed plus x minus the cosine of x. Now it may be hard to believe, but where you're at in calculus, you're actually going to be able to take this derivative mentally in about 10 to 15 seconds in a very, very short period of time that's going to happen for you. But right now, the only thing you know is the limit definition of taking a derivative, and that's going to be really tough to plug into that f of x plus h minus f of x. I don't want to take x plus h and raise it to the fourth power. I don't want to do cosine of x plus h and look at some of those angle addition identities to try to split it up. So right now, this particular derivative, this derivative would be very difficult. Very, very difficult to take using simply the limit definition of the derivative. It would be almost impossible to do. So one of the things we do have, and we don't get to use it all the time, but occasionally we'll have a calculator active question that asks us to find the derivative at a point. And so we can use our calculator. The calculator can evaluate the derivative at a point. And the calculator that I'm going to use for this demonstration is going to be the Texas Instruments TI-84. And so I'm going to give the instructions for it. It's probably the most common calculator that's out there. And so I'm going to list the instructions over here to the left. But what I want to find is I want to find f prime of 4. I want to find f prime of negative 8. And I want to find f prime of negative 2.5. So the first step in terms of doing this for your TI-84, and this is also going to be true for any calculator that you use for this class, is you want to first of all make sure your calculator is in radian mode. In calculus class, you're going to be working in radians. I know physics uses degrees, but we use radians. On the TI-84, if I can put it on here, you'll be able to see right at the very top here, it says that it's in radian mode. If that says degree, you need to change it. You can do that by pressing mode, and then you would have the options down here to toggle between radian and degree, but you want to make sure that it's in radian mode. The next thing that you need to do, if you're on that screen or if you're looking at a graph or whatever that you're doing, you want to go back to the main calculator screen. So go to the main calculator screen, and to do that, you would press second and quit. And so I don't want to be at this mode. I want to press second and then quit, which was mode. I want to go back to that blank calculator screen that we're about to type into. So here's where the action starts in terms of taking the derivative at a point in your TI-84. You're going to press the button that says Math there on the left side. And I'll try to do button pressing here in brackets so you can kind of tell that that's a button. But you want to press this Math button right here on the left side. You get a lot of options, some of which you've probably dealt with. You've got the cube root, you've got the nth root, things like that. But the option you're actually really interested in here is option number 8, the one that says NDERIV for derivative. So you'll choose option 8, and we'll take a look at what popped on the screen right there. But we choose option 8, which again says that NDERIV, something like that, and that's an open parentheses that it has as part of its notation. So that's the option you want. Now then, let's take a look at what's on the screen here, and I'll see if I can't get it to kind of balance out a little bit and focus and See if we can't. There we go. That's a little bit better. So you'll already see that there's 3 boxes here that we're going to be able to type into. And so it's going to be important that we understand what it's doing. The first thing that it's asking us to type right here, what we're going to type, is we actually have to establish a variable that we're taking the derivative with respect to, which in this case is going to be x. So I'm going to press the x button right there. You'll notice that it filled in the x right there, and you can see d over dx, meaning we're about to take the derivative of this function. You can see this vertical bar means we're going to evaluate it at x equals, and that's going to be where we're going to put the value we're evaluating. Right now, the reason why you do that, you actually do have to establish a variable. Later on in this class, we'll look at taking derivatives with respect to other variables, and so you do have to tell it that, yeah, we want to look at it with respect to x. So after you choose option 8 and you're looking at the notation, you want to go ahead and choose x as the variable. Even if the function you're working with on paper is like f of t, where the variable's time, for what you're doing, you can very easily just establish it as x for your calculator. It doesn't need to know the difference. So after you choose x as the variable, the next thing that you can do is you can type into the parentheses or the argument, and that's where the function's going to go. So then you can type the function into the argument. And the function is going to be this guy right here, x to the 4th plus 3x cubed plus x minus the cosine of x. So I'll type that in, x to the 4th plus 3x cubed plus x minus the cosine of x. And it's that cosine of x where we really have to make sure we're in radian mode right here. So I've got the function typed in, and now the last thing that I need to do here is I need to, if I can get the camera to focus on the calculator again, I need to tell it what to evaluate it at what x value right here. Well, that's where I go back to what we said we were looking for. We wanted to know f prime of 4, f prime of negative 8, and f prime of negative 2.5. So the last thing that I need to do is I need to select or type in the value of x to evaluate the derivative at. And so for the first case, it's going to be f prime of 4. So I want to evaluate this derivative at 4 and then press enter, and we get our answer. So the last thing here is we want to press enter, and there's our answer. For the sake of this class, I prefer to round to 3 digits. So if I look, this is taking the derivative of this function at x equals 4. So I can say f prime of 4 is 400.243, which also means because that's positive, it's increasing. And in fact, it's increasing pretty steeply at that point if the rate of change is just over 400. Well, now I need to know f prime of negative 8 and f prime of negative 2.5. Fortunately, I can scroll up and highlight what I typed in there. It'll reproduce it, and now I can go and change the 4 to negative 8, press enter, and I can see f prime of negative 8 is negative 1471.989, and because it's negative, that implies that at negative 8, that function is decreasing at a very, very steep rate, even steeper than it was increasing at 4. And then if I do the same thing for negative 2.5, I can see that I'm still decreasing there at a rate of negative 5.848. So not quite as steep, in fact, kind of a little bit more gradual compared to the other two, but it is definitely decreasing at negative 2.5. So this is how you can use your calculator. You can use this to check your work a lot of times to make sure that you've taken the derivative correctly, especially if you're evaluating at a point later on in your work. And so this is a really nice way to use your calculator to kind of check your work as you take derivatives at a point.